So it is a question from January 22nd JEE Main Shift 1 morning, in which of the following complexes the CFSE delta O will be equal to 0. So CFSE here, it is nothing but crystal field stabilization energy. For example, I am going to take the complex K3 Fe SCN 6 times. I am going to verify the options from the option 4. And the oxidation state of the central atom iron, it is +3 in this complex. Then it will be 4s0 3d5. 4s0 3d5. And one more point, 4s0 3d5, it is nothing but the electronic configuration of the iron 3 plus, and here it is an octahedral complex. According to crystal field theory, the splitting takes place with the degenerated d orbitals. So whenever the ligands approaches a central metal atom, the easy orbitals are getting more energy when compared to the T2z orbitals. So the total 5 electrons are there, first electron and second electron and third electron. SCN is a weak field ligand, fourth electron and fifth electron. Whenever the electron entering into the easy orbital, it gains energy plus 3 by 5 delta O. And whenever the electron enter into the T2z level, it is going to lose energy minus 2 by 5 delta O. Crystal field stabilization energy is equal to minus 3 into 2 by 5 plus 2 into 3 by 5 delta O. So that will be equal to 0. So K3FeCN6 is having delta O crystal field stabilization energy as 0. The products formed in the following reaction, here it is the nitrobenzene is given. So here it is the nitrobenzene. When nitrobenzene reacting with bromine in the presence of acetic acid, bromonium and electrophile is generated and electrophilic substitution takes place. NO2 is the meta director. Bromine attacks the meta position to the nitro group, and tin in the presence of HCl, which reduction takes place for NO2 group. Then NO2 has been changed to NH2. You can get NH2 here, and here it is Br, metabromelain. And this metabromelain, on reacting with NaNO2 HCl at 273 kelvins, diazotization takes place. Then the primary aromatic amine like aniline undergoing diazotization to give and triple bond and positive charge Cl minus, benzene diazonium chloride, and Br you can get here, and which is on reacting with C2H5OH, which is a good reducing agent. So which reduces the benzene diazonium chloride to the benzene, and you can get bromine here, so you can get bromobenzene. The reducing agent has been oxidized to acetaldehyde, CH3CHO. So the option 3 is the correct answer for this question. Bromobenzene is there and acetaldehyde is also there. So in this question, some CO2 was kept in a sealed container at a pressure of 1 atm and 273 kelvins. The entire amount of CO2 gas was later passed through the aqueous solution of CaOH twice. The excess unreacted CaOH twice was neutralized with 0.1 m of 40 ml HCl. The volume of the sealed container of CO2 was x. Then x is dashed centimeter cube, nearest integer. So entire amount of CO2 react with the exactly half of the initial amount of CaOH twice present in the given aqueous solution. So first of all, how to understand the question here, initially CO2 is there. CO2 is passed through CaOH twice. CO2 is going to react with the CaOH twice, and the CaOH twice, half of the amount only reacted with CO2. And the remaining amount of CaOH twice is get neutralized with 0.1 m 40 ml HCl, 40 ml HCl solution. So you have to find if the volume of the sealed container of CO2 is x, then you have to find the value of x. So now what I am going to do is, the number of milli equivalents of HCl which is used to neutralize the CaOH twice is molarity, normality into volume in ml. HCl is a monobasic acid, that's why molarity and normality both will be equal. Then 0.1 into 40, that will be equal to 4 milli equivalents which are used to neutralize the HCl, which are used to neutralize the CaOH twice. In any reaction, one reactant milli equivalents is equal to the another milli equivalents of that particular reactant. Then milli equivalents of calcium hydroxide which get reacted with HCl is also equal to 4, which is the half of the amount which reacted with the HCl. The total milli equivalents of that particular calcium hydroxide present in the solution is 8. Total 8. Out of 8 milli equivalents, 4 reacted with the HCl, 4 reacted with the CO2. So here I am going to take that, we know that milli equivalents is equal to number of millimoles into n factor. Then number of millimoles of CaOH twice is equal to, the milli equivalents of CaOH twice get reacted with CO2 is only 4, and the n factor for CaOH twice is 2, because calcium hydroxide is a diacetic base, that is equal to 2. That implies 2 millimoles can be written as 2 into 10 to the power of minus 3 moles. 2 millimoles get converted to 2 into 10 to the power of minus 3 moles. This is about calcium hydroxide. That is the calcium hydroxide moles that reacted with CO2. So if you write the equation between CaOH twice and CO2, CaCO3 plus H2 is formed. That means every 1 mole of calcium hydroxide can reacting with the 1 mole of CO2. So the number of moles of CaOH twice is reacted with the CO2 is 10 to the power of minus 3. Then CO2 also get reacted with the CaOH twice is 2 into 10 to the power of minus 3. So the number of moles of CO2 get reacted in this equation is 2 into 10 to the power of minus 3. Then volume of CO2 present in the initial conditions is the number of moles 2 into 10 to the power of minus 3 into gram molar volume is 22,400. That will be equal to 2 into 2 22.4, that will be equal to 44.8 ml. That can be taken as 45, nearest integer. It is a question from chemical kinetics. The molecule A changes its isomeric form B by following first order kinetics. The temperature of 1000 kelvins. The energy barrier with respect to the reactant energy for such isomeric transformation is 191.48 kilojoules. So the temperature T is equal to 1000 kelvins and energy barrier is given as 191.48, that is nothing but the activation energy is equal to 191.48 kilojoule per mole. Frequency factor A is equal to 10 to the power of 20. The time required for 50% molecule of A becomes A. It is the first order reaction. We know that T half is equal to 0.693 by K. If you find the value of K, you can find the value of T half. So for first order reactions, K is equal to A into e power minus A by RT from the Arrhenius equation. The value of A is 10 to the power of 20 into e power minus 191.48 into 10 to the power of 3 joules by the value of R is 8.314 joule kilon inverse mole inverse The temperature is given as 1000. This 1000 gets cancelled. That will be equal to 10 to the power of 20 into. If you solve this one, you can get e power minus 23.031. That can be written as 10 to the power of 20 into e power minus 2.3031 into 10. That can be taken as 10 to the power of 20 into e power minus 2.303 can be written as e power minus ln 10 into 10. So, if you are cancelling this one, e power and ln 10, you can get 10 power 20 by 10 power 10. That will be equal to 10 to the power of 10 seconds. Then t half is equal to 0.693 by 10 power 10. That can be written as 69.3 into 10 to the power of minus 12 seconds. 10 to the power of minus 12 seconds can be taken as 69.3 picoseconds. So here the question is, consider the following reaction sequence. Nitrobenzene is given, tin HCl, NaNO2 HCl, 0 degree centigrade, Cu2 Cl2 and Na in the presence of ether. Product A is formed. You have to find the molar mass of the product formed. Let us consider the nitrobenzene. Nitrobenzene reacting with tin in the presence of HCl. Reduction takes place. Nitro group and reduction, you can get aniline. Aniline undergoes diazotization to give a compound called as benzene diazonium chloride. Benzene diazonium chloride on reacting with Cu2Cl2, Sandmeyer reaction takes place. Then you can get the compound chlorobenzene. Chlorobenzene on reacting with sodium, then you can get wood fitting reaction takes place. Then you can get the compound biphenyl. So you have to find the molecular mass of the product form, biphenyl molecular mass. So biphenyl, it is having C6H5 which is connected with C6H5. So C6H5 molecular weight, if you are calculating 6 into 12, that is equal to 72. 5 into 1, that is equal to 5. 77. So C6H5 units are 2 are there. 77 into 2, that is equal to 154 gram per mole. 154 is the correct answer for this question.